All right, y'all ready? So we're gonna work all the way pretty much to the top of the last page. That way Wednesday is just an easy day. You can catch up on problems you missed last time. But we're gonna try to kind of get a lot done so that Wednesday's easier. Yes, sir. It's a district exam, so I don't know, and I can't see it till it opens, which it doesn't open till Friday. But it'll be curved though, if that makes you feel any better. And it'll be the square root curve, which means you need like a 40 to pass, basically. Like or I guess a 49 to pass. Okay, so take a look at number 9. Okay, first question. For domain, we're measuring side to side. How far forward does it go? Infinity. How far backwards? Negative infinity. So for the domain, what can we say it is? Okay, all real numbers except. Remember that all real numbers means it hits every single x value between negative infinity and positive infinity. Okay, that is not the case because we have vertical what? Asymptotes. What x's can we not cross? -5. Okay, I have one at -5. One at where? Okay, so -5, one at 1. Okay, so we know we have to accept those. Anything else that we're gonna have to accept that got skipped? -2. Remember that holes and vertical asymptotes are open. That means there's not an x there. So you would put except. X cannot equal -5, 1, -2. But remember, you have to accept all the holes, all the asymptotes. For the range, how low does your graph go? Okay, how high? Okay, and does it hit every single number in between? It doesn't hit 0 because I have what type of asymptote going across at 0? This would be called a horizontal asymptote. Very good. Okay, so we do all real numbers except y cannot equal 0. Okay, and then if there were other y's that had to get skipped, you could include those as well. Okay, x going to negative infinity, which end of the graph is that? The left end or the right end? Okay, this is the left end. And what is that end doing as I trace it out? Is it increasing forever or is it increasing towards a specific value? Okay, so it is increasing, it's getting closer and closer to what y value? 0. So you would put that it's approaching 0. Remember, if you put y is going to infinity, that means that this graph keeps going up. But because of that asymptote, I get stuck where I can't cross 0. So I can't keep going to infinity. I can only go up to 0. Other end, what happens over here? Same thing, so also approaching 0. Okay. Do we remember what a removable discontinuity is? It's the fancy way of saying a hole, okay? And on your exam, it is gonna call it a removable discontinuity. Okay, that's like the mathy math term. We've been calling it a hole, but removable discontinuity is the same. So where's the removable discontinuity? Okay, at -2. And then it says we have vertical asymptotes at x equals, we already named those, but -5 and 1. Okay, one more thing. When on example 7, it asks you to write a possible equation. Number 9 doesn't ask you to do that, but I had a lot of people last class asking me how to do number 7. So we're gonna do that for number 9 so that you can look back at it if you need to. Okay, if it said add a part F to write the equation that goes with that graph, you're gonna open a big fraction. And then remind me, where is the hole in the graph? What number? The -2 would be what parentheses? X plus 2, right? Because remember, we switched the sign? And where do holes go in the equation? Top, bottom, or both? So I put in X plus 2 in both spots. Do I have any vertical asymptotes? We have one at -5, one at +1. Where do those go? Top, bottom, or both? Bottom only, and if it's a -5, what do I write for the parentheses? +5. And for my +1, I would change it to a -1. Do I have any x-intercepts to go on the top? Remember, could it cross the x-axis, right? So for my x-intercept, we're gonna say that we have none. So then that means no extra x's go on the top. Last thing, horizontal asymptote, what did my ends curve off to? That means it should be a bobo, is it? Do I have more x's across the bottom than I have on top? Yes. Does that make sense? So looking at the features of the graph, you should be able to kind of sort of go back and put your equation based on where those features go. Holes are top and bottom. Vertical asymptotes are bottom only. X-intercepts are top only. All good with that? All right, go ahead and turn the page. Okay, the next page is matching. I am going to assume that it would be easier for you to do matching with a graph on your own. So I'm gonna help you instead of with 10 through 14, you're just picking the picture. I'm gonna help you with 15, 16, 17. Okay, but they're all pretty much matching. So let's review how to find a vertical asymptote. Where would vertical asymptotes happen in the equation? Top, bottom, or both? Okay, the bottom. Okay, and remember, can it be on the bottom and also on the top? Can it be in both, or it has to only be in the bottom? So I'm gonna put bottom only. I want you to look through your answer choices. A, B, C, D, E, F, and tell me which of those does not have something only in the bottom. Okay, so for B, I have an X minus 6 that would cross out. And what does it create when they cross out? A hole, but is there still something left on the bottom? That's gonna have a VA. Okay, look at A for it though. What happens with the X plus 3s? Now they're holes, and do I have another X on the bottom to give me a vertical asymptote? Okay, then A can't be the right answer. There's one more answer like that. Can you find it?
C.
It is gonna be C. See the X plus 3s? If it's in both, that means that I'm gonna have a hole, but I'm not gonna have a vertical asymptote, and all of these answer choices say I have to have a B. Okay, out of the remaining things, let's review how to find an oblique, a horizontal, and not have a horizontal. These are your Bobo, Bott, and Betsy rules. If I want Y to be 0, do I want it to be a Bobo, a Botton, or a Betsy?
Bobo.
That needs to be a Bobo. So out of the remaining answer choices, can you tell me which one's a Bobo? And what does Bobo stand for? Just so we're on the same page. Bigger on bottom, ends go to 0. So out of those answers that I haven't eliminated, I eliminated A and C. We did not eliminate B, we kept B. Okay, B is the correct answer, because how many X's are there on top? Only 1, and on bottom there are 2. So B is the correct answer for Bobo. Okay, out of the ones that are left, we want an oblique asymptote. And then we want to have no asymptote. Let's review the difference. Both of them are Bottons. Except, do you remember for an oblique, that's the same as a slant asymptote, if you want to put that? Okay, for a slant asymptote, how much bigger does the top have to be than the bottom? Do you remember? Exactly 1. It can't be more than 1 bigger. So we already did B, so we're really only looking at the bottom row. Two of those have the top exactly one power bigger than the bottom. Which letters am I talking about? E and D. Now notice the difference. D is multiplied out for you already versus E is in parentheses form. But this is an X squared versus an X, so it's one bigger, so that's gonna go here. And then E is the same way. I have X times X, that's X squared over X, which is also gonna be a slant asymptote. Okay, versus for F, how many X's do you have on the top? X squared times X would be X3 over X. And so would that count as a slant asymptote?
No.
No, because remember, slants have to be one bigger on top than on bottom. So I'm gonna go ahead and put F for 17. Do you feel like you can do that? Okay. We're gonna go through number 20. So we'll do maybe two more examples. Let's do number 18. Okay, to find the oblique asymptote, remember, top has to be one power bigger than the bottom. To find it though, you're gonna actually do long division. So let's put to find slant, do top divided by bottom. Okay. Okay, use long division. So we're gonna do number 18 because number 19 works out a little bit easier. So I'm gonna do 2x plus 2 divided into x squared plus 5x minus 6. Okay, now the first one on this is a little bit tricky. You actually had a question like this as a bonus a couple tests back. I want to take my 2x and I want to turn it back into a regular x squared. Will I need any x's to go from 2x to x squared? Yes. And what number will I need to use to take my 2 back to a 1? It'll be a fraction. 1/2 x, very good. Okay, so 1/2 x. Then remember, once I pick my multiplier, I'm gonna multiply it right here. So what's 1/2 x times 2? Well, half of 2 is 1x squared. What about the 1/2 x times the regular 2? That would be a 1x, very good. Then what do I do with the signs on that row? You flip them, so it'll be minus minus. What's 1 minus 1 in the front? Cancels out or goes to 0. Always, that should always happen, or you picked the wrong thing, right? Then what's 5 take away 1 here? 4x squared, or 4x, sorry, and then what do I do with the 6? Drop it down. And then I would ask myself, what do I need to times the 2 by to perfectly now match this 4x? Another 2. And then 2 times 2x is 4x, 2 times 2 is plus 4, but then what do? Switch the signs to be minuses, very good. 4 minus 4 in the front, what happens? Okay, should always cancel out, and then -6 minus 4 more, what's that? -10. Because remember, they're both negative. What's that last number called, starts with an R? Remainder. Okay, but remember that your asymptote is what you've got at the top. You actually don't care about the remainder for asymptotes. You're just finding what would I have to divide by. So this is your asymptote right here. Okay. So I'm gonna put asymptote is top equation. Okay. And remember, the remainder doesn't even matter. So a lot of times when we were doing this unit, we wouldn't even like finish the division, if you remember that, because you don't need the remainder. Okay, do you feel like you could do number 19? By yourself? Okay. So then last thing we're gonna do 2 of the examples from 20, and then I'm gonna give you a little bit of time to work, and then we'll come back and do some more. So for number 20, if you have a number in the very front that controls a vertical stretch or compression. So let's take a look at letter B. Okay, we're gonna do B. What is the negative in the front gonna do? Okay, flip. So I'm gonna put ROXA, because a lot of y'all put that. Okay, but that stands for reflect over X axis. Okay. And then to show what did that, I'm gonna put a negative up here at the top. So the negative is what's making it reflect across the X axis. Okay, the next thing I see is a 1/3 in the front. Will that be a vertical stretch or compression? It will be a compression because 1/3 is less than 1 is the cutoff. Vertical compression. And then I'm gonna put that my A is a 1/3. So the negative flipped it. The 1/3 compressed it. Okay, then I have two more numbers that I see in my equation. I have a -7 next. What is that gonna do? Shift which way? To the right 7. Then I'm just gonna put and my last number would be that +6, which way is that gonna move us? Up 6. You remember that? Okay. Now, I want you to take a look for me, please, at letter C right below it. Or actually, never mind, let's do D. Okay, so first thing I notice is I have a 10 in the front. Will that be a stretch or compression? Okay, so I want you to put vertical stretch. And then I'm gonna put A equals 10. Okay, then, do you notice the 2 in the middle? Okay, we did talk about this on the QSA review. If you have a number between the parentheses, okay, or like not out in the outside, but like in front of the X still, that's a horizontal stretch or compression. Here's the trick though, because it's with X, it's still gonna do the reverse, just like this number does. So normally, what would a 2 do? A stretch or a compress?
Stretch.
Normally, it would be a stretch, but you see how it's with X in the little cubic root? That means it's actually a compress. Okay, so for the purple number that I just boxed right there, this is a horizontal compression. And remember, why is it the opposite? Because it's with your X. Okay, and so instead of a ×2, what's actually gonna happen is it's gonna be by a factor of 1/2. So instead of a ×2, it's actually gonna cut your horizontal distance in. Okay? But that's only if you have an extra number kind of between, still with X, but also kind of in the front, but not in the way front. Then your other two numbers, you have a -6 and a +7. What does the -6 do? Shift to the right 6. And which other way? Up 7, very good. Okay. All right, then actually I lied. Let's just do 21 since it's almost the same. Here's your parent graph. This is 3 to the X. You can put it in the calculator if you want to. Okay, but this is what it looks like. You have a horizontal asymptote. If you want to put your dotted line is right here. And I want to take that graph and I want to turn it into this graph. So let's observe what the differences are and how I would adjust that parent graph. The first thing I notice is I have a -2. What does that mean that I should do horizontally? Which way are we gonna move it, left or right? To the right 2, and then at 5. So I'm gonna put shift to the right 2 and up 5. So that would now be here. Okay, then I want you to draw in your horizontal asymptote, which would run like this. So I took that graph and I'm basically just kind of like sliding it over and then up. Okay, next question. Your parent graph, your first dot, because remember, you can't touch that asymptote. How many boxes is it away from the origin right here? It's 1 box above. That's the parent function. Will this graph also only be 1 box above? What does this number do? Vertical stretch or compression? Stretch. So instead of only being 1 box away, how many boxes am I gonna place that dot? 4 boxes away. So I'm gonna count up 1, 2, 3, 4. And then I'm gonna draw basically the same shape. But it's gonna have a vertical stretch of 4. Okay, and the way it's phrased on your exam is it's a vertical stretch by a factor of 4. Okay, but it's gonna take that distance of 1 box and stretch it to where now it's 4 boxes away. Okay, do you kind of feel like you can do that? All right, I'm gonna give you a little bit of work time and then we'll work some off the back page in maybe like 15 minutes. Are you ready?
Yeah.
All right, y'all get to work, please. Yeah. You can actually use them.
Okay.
And then you don't have to turn in the review, just the test.
Okay.
Yes. Uh-huh, just take the little secret pass. Yeah. No, that's just like, that tells you the shape. So if it's it's a 3, then that's a squiggle. But they all follow the same notes. Shut that mouth. Yes, ma'am.
That would be.
Uh-huh. That'd be a minus 4x, because you're multiplying. Yeah, you multiply by this whole thing, so you do x times x gives you x squared, x times minus 4 gives you minus 4x. But then don't forget, you're gonna switch the signs on that row before you.
Yes, for the top.
I mean, some of y'all are saying no, but I just wanna be done, I hate to say. So I'm only hearing the 2 people that said yes. Yes. Alright, look at 22, 23. Okay, 22, when you're expanding, everyone gets their own log. Versus 23, when you're condensing, you're trying to squish them all back into 1 log. So we're gonna do 23 first. What numbers should I move for step 1? Okay, we're doing 23. The numbers in the front, very good. And do you remember the numbers in the front can pop up as exponents?
Yes.
So I'm gonna cross out my 3, put it up top. What other number can I put up top? The 1/2, right? And what else? The 1. So I have log x minus 2, now cubed. Plus log x plus 10 to the half. Minus log y plus 5 to the 1/3. Okay, next step, 1/2 and 1/3 are special powers because they can turn into what? Do you remember? Roots. A half turns into a what? And a third turns into a cube root. So let's redo those. So I'm gonna have log x minus 2 cubed stays the same plus. But this log is gonna turn into a square root of x plus 10. Now I want you to think about why, because a 1/2 and a square root power are the same thing. Okay, then I have a minus, and I'm gonna turn my y plus 5 to be inside a cube root. Okay, from there, notice I still have 3 separate logs. I need to condense them into the same log. So for your final answer, put your last log here. We're gonna put them all into the same one. I'm gonna start with the x minus 2 cubed. And then when I put the square root of x plus 10, will I put it next to it or on bottom divided? Why next? That is correct. Because it's a plus, and plus turns into multiplication. So I'm gonna put my square root of x plus 10 next to it. Where should my y plus 5 end up though? Bottom, because what does it have? A minus. So remember those rules. You will have a rule sheet for your exam that'll have the rule on it, but hopefully you just know. Okay, so condensing, you're going all back into just one book, and there's a question almost identical to that one. Okay, take a look at the next row. We're gonna do I guess maybe 25 or 26? 25, okay, what do you do with the number in the front? And no, you can't just times these together and make it 10. You gotta divide it first, very good. So I'm gonna divide the 5 out of the way. What is 40 divided by 5 now? 8. So that's 2 to the 3x equals 8. And then from here, I wanna find a common base. I don't wanna get the chart out because I bet you remember, what is an 8 is a base 2? 2 to the what? 2 cubed, or 2 to the 3. And you remember that chart, you'll have it for the exam. Okay, but 2 to the 3 and 8 are the same. So I'll have 2 to the 3x equals 2 to the 8. And then I'm gonna write here, use common base chart. Okay, because for your exam, you'll have that. And then why do I want them both to be a base 2? What can I do now? Yeah, now you can eliminate the base and just set the tops equal. So it'd be 3x equals 3. And then what? Which means that x equals 1. Very good. If you need that base chart, it's on several versions of your notes and on your test review. Okay. All right, last thing that we're gonna cover today are inverses. Okay, so let's do number 27. To find an algebraic inverse, it has been a while since we did this. This was quarter 1. You are going to switch the x and the y, and then you are going to solve for y equals. Okay, those are the steps. Switch the x and the y, and then get the new y by itself. So for example, if it says x minus 1 cubed plus 5, what am I gonna change that to? Instead of x minus 1, what am I gonna switch it to? Y minus 1. Cubed plus 5. And then instead of a y equals here in the front, because remember y and f of x are the same thing, I'm gonna change that to an equals x. So instead of a y equals, now it's an equals x. Okay, and then remember, once I switch the letters, I wanna get the new y by itself. What would the first step be to that? That 5 has to go with the what? With the x on a minus. So I have plus 5 minus 5 crosses out. Y minus 1 cubed equals x minus 5. Okay, next step, do I add the 1 across? No, what has to happen first? Yeah, and so if it's a third power, to cancel that out, I'm gonna use a third root. So put a little 3 in the elbow. Remember, your third root and your third power are gonna cross out. So what's the only thing I have left now? Y minus 1 equals the cubic root of x minus 5. And then from there, to get rid of the -1, we'll do what? Plus 1 and plus 1. Can I add the 1 directly to the 5? No. So it'd be y equals cubic root, I ran out of room, x minus 5 plus. Okay, now I want to point out what we talked about when we originally covered this. Okay, so here's your original. And here's your inverse. This one had a -1 on the inside. What does the inverse have? +1 on the outside. This had a +5 on the outside. What does this one have? -5 on the inside. This one had a cubic power. This one has a cubic root. So go ahead and turn the page to your stopping point. Okay, when you're doing this section, okay, this is where I would stop for today, do it, but then maybe take a break. We'll finish this next time. Okay, I wouldn't resolve all of these, just look for the pattern and see if that pattern's there. Outside and inside should be reversed. If that doesn't happen, then you know they're not truly inverses, okay? All right, we are gonna still do one more, but for that question, make sure that's what you're looking for. Don't resolve all of those, that's unnecessary. Okay, for number 29. 29 is a little bit confusing the way that it's worded, but there's a question just like this on your exam, so I want to make sure you know how to do it. It says f of x equals 2x plus 5. Will you put that into your calculator, please? Okay, and then I want you to go into the table, okay, because we see we have a table here. So y equals, we're typing in 2x plus 5. I'm gonna go into my table. Second graph to open the table. Also for your exam, if you like Desmos better and you're more familiar with that, you can use that too. Okay, anyone need help getting here? Okay, from here, should I look up 5 and then put 15? Should I do that? No, because this is f of x. And what chart am I trying to fill in? The inverse. And what's the order for f and f inverses tables? They should be what? Flipped. So come right here. Recall that the points for f inverse are the reverse of the points for f of x. So in my calculator, I have f of x. Then if I want 5 as an x, where do I need to find it in the chart? As a y, very good. So can you tell me for which point my y is a 5?
0.
And so if it's 0, 5 for f, what would it be for f inverse? 5, 0. Does that make sense? Because you're having to look it up backwards because they're giving you f, but they're asking you questions about its inverse. So for the next number, I want 9 comma what? Well, then in my calculator, it's going to be something comma 9. Where is it?
2.
2. And then for the last one, 11 goes with 3. Okay? But then I'm gonna put in the calculator. You have x comma f of x. And then it would be 0, 5, 2, 9, and 3, 11. Okay, but remember, you're using the calculator to look up f, but you're not answering questions about f, you're answering questions about the inverse. Make sense? Okay, very last thing that I want to do, number 28, asks you to find the inverse of f of x equals 7. What letter is f of x the same as? So this is really the same as y equals 7, right? What is step 1 for finding an inverse? Okay, then you have to have an x and a y to be able to switch them. Does this equation have both letters? Then you cannot do an inverse for it. So I'm going to put here no possible inverse without an X and a Y. So there's a question on your exam that says which of the following doesn't have an inverse? If it has Y equals 7, you can't inverse that because you don't have the other letter to be able to switch them, which is what that first step is. Does that make sense? Okay, if you want to work ahead, I totally don't care to be done, but I'm gonna save that last couple of questions for Wednesday. Okay? Please don't lose your review. I'm happy to keep yours with mine if you want me to do that. But I would try by the end of class to be done all the way through number 30. Then we'll pick up with 31 on Wednesday. Y'all's exam is not, y'all are the last one, right? So you have forever to just chill, basically. You won't have any new assignments after the review. Hudson, did you catch the first question we did?
Yeah.
Okay. 23, you don't need to see mine. Okay.